Welcome back to the satellite remote sensing module. In previous module, we learned about the availability of satellite climate data records. In this module, we'll start to learn practical skills of using satellite CDRs for climate application. First of all, let's look at the life cycle of using satellite CDR data for climate applications. It usually starts with discovering what data are available for a specific use case, such as monitoring the vegetation change in response to climate. Once we identify the data, we will need to access the data either via the download or directly access the data online. With access to the data, we can start exploratory data analysis to visualize and understand data for our applications. The exploratory analysis often will lead to the further processing of satellite data before they are used in the final analysis. Finding the right data is usually critical for using satellite data for climate studies. You should use the different characteristics that we learned in the first module to help you determine the right datasets. Spatial and temporal resolution often affect if a satellite dataset can be used for different satellite applications, like we learned before. If we want to study vegetation phenology, we often need frequent observations and high spatial resolution data to help us understand the diverse response of plants to climate. On the other hand, if we are interested in climate variability and other large-scale and slow-evolving phenomena, satellite data at lower spatial and temporal resolution may be sufficient, such as study ENSO. For applications for drought and heat wave, we may need data at least with medium spatial resolution and more frequent visit time to understand the rapid impact on the ecosystem and the society. The diverse set of satellite datasets can enable a wide range of climate applications from local to global scales beyond the few examples that we listed here. However, we will always need to understand the quality of the satellite datasets before using them for climate research and applications. The quality that may affect the utility of satellite data for climate applications include the quality of original sensor data, the consistency between different satellites across time, and how accurate is algorithm used to retrieve the physical variables such as temporal or rainfall. This information is usually developed and provided by the producers of satellite data in the form of data quality flag. The quality flag associated with satellite should be used to filter out how those low quality data should not be used before using them for our climate applications. The quality flag often comes with detailed user guide documentation to help you decide which data should not be used. The left table is an example of the explanation of how to use a quality flag to select high quality data from the Normalized Difference Vegetation Index, or NDVI, that you will learn more in the tutorial. The factors that often affect the data quality of satellite CDRs include low quality in raw sensor observations because of satellite or sensor deterioration, such as satellite orbit drift throughout the time, as well as the sensor malfunction. Also, the low quality in raw sensor observations because of environmental conditions, such as thin cloud for the visible sensors and the air aerosol in the air, can also affect the data quality. And also, the errors and uncertainty in algorithms used to estimate physical parameters can also cause low data quality for the satellite applications. In the tutorial today, you will learn how to find, access, and open one of the NOAA climate data records, Normalized Difference Vegetation Index, or NDVI, which can be used to monitor vegetation dynamics on land. And you will learn how to use quality flag information from remote sensing dataset to filter the data that is proper for climate analysis.